Hi my dear students, welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. How are you all doing? So, can you please confirm, am I audible and you can see me, right? So, those students who are regularly attending the class, thank you very much and maintain the regularity. And we are from the Infinity Land YouTube channel. We are providing all kinds of subjects in the NEET level preparation, and please join our classes on the regular basis and get prepared well for your NEET examination. All the best my dear students. Hi बेतु, राधे राधे. मेरा आवाज सुनाई दे रहा है क्या बेटी? राइट, आज हम चर्चा करने वाले हैं बेहतरीन टॉपिक मॉलिक्यूलर ऑर्बिटल थ्योरी. मेरा वॉइस क्लियर नहीं है अभी? Is it fine? Just check it once. Just check it once. Now is my voice is clear? Please confirm Betu, because every student who is attending my class has to witness this. Voice is clear? Fine. Shall we start? Yes, thank you. Perfect. And the molecular orbital theory. You completed atomic structure, periodic classification, and chemical bonding. In the chemical bonding, we discussed the ionic bonding and 𝑣𝒂𝒂𝒊𝒕 theory, hybridization. But here, the molecular orbital theory, if you see the previous NEET examination, in the last decade, 10 years, you got 6 times the question based on molecular orbital theory. That is the impact this MOT can give you. Believe it, and this is looks so complicated, but I'm going to give you a simple trick to handle this molecular orbital theory. Get ready, my dear children. Here this molecular orbital theory tells you the behavior of the molecule, the formation, the process of formation of a bond, and the magnetic properties and the electronic configuration. And let's see, before entering into this molecular orbital theory, I can guarantee that at the end of the session, 4 marks will be in your pocket. Ready? Get ready with that. Everybody, take a pen and paper, write the noteworthy points, and please attend this class without any breaks over here. Let us see this session, and please like this session and share with your friends. In लोगों को भी फायदा होना चाहिए, and subscribe to Infinity Land NEET YouTube channel. Dear children, before going for this MOT, I have a couple of promotions. One is a score examination. What is the score examination here? Yeah, this score examination. So why this score examination and what it is? This score examination is India's largest scholarship examination. Why it is India's largest scholarship examination? It gives you the scholarship worth of 2.5 crore cash rewards. How can we give? We are the unicorn. 𝒑𝒑𝒐𝒓𝒕 Academy is a unicorn in the education industry in India. Hi, Basti, Pihu, MOT, get ready. Okay, so 2.5 crore cash rewards and also 350 crore scholarships be here. Depending upon various courses, you can go for the scholarships. Up to 100% scholarships available. Your voice is not coming. Betu, is my voice is coming? Betu, is my voice is coming? Please confirm. Please confirm, is my voice is coming? Betu? Right. Just a minute. Yes, yes, my voice is coming, and Masti with Asha. Okay, please confirm my voice is coming or not. My voice is coming or not, please confirm, so that we can start this molecular orbital theory. We can start. Is my voice is coming? Please confirm. Just wait for a minute. Wait for a minute. టైమర్ ఉందా? టైమర్ ఉంది అక్కడ లేదా? Is my voice is coming? Yeah, the sound is oscillating is there and vibration in the background. Please check it once. Children, fine, Betu? Just wait for a minute. Tech team is working on it. Let us go ahead with a minute's time so that we will be closing this. Okay. Laiva, hi. Assalamu alaikum. Cancel. Okay. Laiva, is my voice is audible? Right. Can we continue, Betu? Right? Fine? Okay. So let's say the score. India's largest scholarship examination. This India's largest scholarship examination. Why it is said so? Because it has 2.5. We are offering 2.5 crore rupees of the cash rewards and the 350 crore rupees of these various rewards. And also, have you ever dreamed about the NASA trips in the space shuttle programs and the United States of America? Yes, we are. Acha nahi aa rahe? Okay. So let's see, maybe some technical internet issues or so. Let's go ahead with this. So NASA trips are also is given. Sound is hesitating. Okay. Fine. So let us go ahead as long as what you can do, please. And this NASA trips, can have you ever dream about this NASA trips? Definitely. The students who do well in this core examination can be given an opportunity to visit this NASA, and also exciting gadgets like you see pen tablets, you can see the gadgets, iPads and the laptops will be given. So sound. Okay, up to 100% scholarships. Okay, let me check it once. Okay, so moving ahead, Infinity Learn by 𝒑𝒑𝒂𝒊𝒕 Academy, we are also offering one more amazing thing, that is your NEET test series. What is this NEET test series? Let us see. NEET test series is an assessment platform for the students preparing for NEET examination, my dear students here. So it's the ultimate key to NEET success. It's a success booster. You ask any one of your seniors or rank achievers, they say they prepared well like you, but also they did this NEET assessment program. Whenever you are preparing for any examination, it is required to know where exactly you stand and what you are doing. For that, you need a proper assessment platform. For that, 𝒑𝒑𝒂𝒊𝒕 Academy and Infinity Learn is offering you a NEET test series. And this test series can help you to understand what is your improvement areas, where exactly you stand. This NEET test series is all about 11th standard ko alag hai, 12th standard ko alag hai, and repeaters ko bhi alag hai. It is prepared by these expert faculties from the NEET Academy, the 𝒑𝒑𝒂𝒊𝒕 Academies, and also based on the latest NTA examination pattern it is given. And also you see, It simulates the real-time test taking experience. It simulates the real-time NEET testing experience, and when you do this NEET experience and you're going to do the real-time NEET examination field, so that if you really sit in the NEET examination, you will be having an experience that you already did it, and that gives you a lot of impact when you write your NEET examination. While a description box link is available, you click it and you can do the best. And also YouTube 30 of open code enter करना है, so that you will be getting exactly 30% flat discount on this test series. So mine is over. So shall we start the concept? Shall we start the concept? Yes, is my voice is okay? Right? So let's talk about the molecular orbital theory. Why this molecular orbital theory? Let us talk about, according to VBT, valence bond theory. Let us discuss about what is the magnetic behavior of oxygen. According to the molecular orbital theory, it can be explained, but according to VBT, it is going to be diamagnetic. It is going to be diamagnetic, but when you do the experimentally, it is going to be experimentally. Oxygen is paramagnetic. Do you know that? What is the meaning of paramagnetic? What is the meaning of paramagnetic? If a substance is placed in an external magnetic field, if this substance is attracted with external magnetic field, then the substance is said to be paramagnetic, and the phenomena is known as a paramagnetism. And oxygen, practically, it is going to be paramagnetic. It is going to be paramagnetic, but valence bond theory cannot explain. And the paramagnetic behavior of this oxygen is explained by using molecular orbital theory. Get ready, this molecular orbital theory, I just want to take you in the direct picture, right from the scratch level. It is based on valence bond theory, explains the bond formation and the process of bond formation, and the orbital quantum mechanics and everything is taken into the consideration, and molecular orbital theory is so important. Let us discuss about that, right? बच्चों अभी वॉइस आ रहा है ना? लाइवा अभी वॉइस आ रहा है ना? हेतु आशा clear? So I checked it somewhere, some issue may be there. You all check your internet connections that you can see. So let's talk about the formation of a molecule. So features of the molecular orbital theory. This is an atom and this is an atom. When two atoms are combined, it forms a molecule. चाहिए ये हाइड्रोजन एटम होगा, ये हाइड्रोजन एटम होगा, दोनों मिलके हाइड्रोजन मॉलिक्यूल बनाना चाहता हूँ. So nose or sound is hesitating. Okay, let me check. Tech team is working behind that. Hold on a minute. Just a minute. 1 minute, please. The tech team is working on that. I'll be back in a minute. ఈ కెమెరా తిప్పితే సరిపోతుంది కదా. ఇప్పుడు ఇది ఎలా ఉంటుంది కదా, తిరిగితే ఇప్పుడు
पूरे ऑफ है
चलता पीछे में स्ट्रीम फर्स्ट में
उसमें से ले रहा है
आशिक ఇక్కడ రావట్లా
यार
స్ట్రీమ్ ఆఫ్ చేశారు స్టాప్ స్ట్రీమ్ చేయండి స్టాప్ స్ట్రీమ్ చేయండి ఓబీఎస్ ఓపెన్ చేయండి ఓబీఎస్ OBS ఇప్పుడు ప్రోమోది తీసేస్తాను, అన్ని తీసేస్తున్నాయి, ఈ లాస్ట్ ఒకటే ఉంది, వీడియో క్యాప్చర్ డివైస్ అయితే ఆన్లో ఉంది. ఓకే, ఏది ఏది
ఏది అన్నీ ఆఫ్ ఉంది.
ఫైన్.
ఓకేనా?
సో ఇది అన్మ్యూట్ చేసేసి
यहाँ पे देखो, ये पूरा करेक्ट है. इसमें
దూరం పెట్టాలా? అలా పెట్టాలా?
దీన్ని అనబడాలి సార్. दिख रहा?
అయిపోయిందా? అన్మ్యూట్ చేసి చూడు. Is my voice audible?
Yeah.
Bacho, sorry for interruption here. Can you all able to hear me? Can you all able to hear me? Please confirm. Bacho, please confirm. I was working with the audio device over here. Please confirm. Is my voice is audible? Please give me a thumbs up and fire emoji in the chat box so that we can. Can we? So please confirm. The device is okay. So moving ahead, how a molecular orbital theory can be explained on the basis of this, children, right? Laiba and Beto and the Masti Asha. Let us talk about these features of molecular orbital theory. According to molecular orbital theory, a bonding atom should combine to give rise to the molecule. While it is combined, all the atomic orbitals present in the molecule should combine. So they lose their previous identity and they are going to give you the new identity of the molecular orbitals. You can see here, feature 1, it is going to be, so electrons are associated with the molecules as a whole. You can see here, this molecule, the atom and atom combine and gives rise a molecule. Now it is a molecule. The overall picture entity is going to be a molecular orbital. Bacho. So, Betu, come on, let us see the feature. Another one is going to be feature 2. So, when you learn the subjects like this, you are going to do the best. You can see atomic orbitals. I say it is AO. Good, sir. That's fine, Laiva. And it individual atom combines to form molecular orbitals MO. AO combined to gives, now it is going to be MO. Right? That is the basis of the molecular orbital theory. And the feature 3, energies of the AO combining atom should be comparable. Audio quality is low or here, be feel Rehan. Okay, so still we are working at the same, and you just follow these instructions, and you can see still the animations, that definitely it is going to be self-explanatory. It can be given right. So when the atomic orbitals are combined to give rise to molecular orbitals, the atomic orbitals should be nearly the same energy or exactly the same energy, and is going to be how many molecular orbitals are there. So जितना number combine कर रहे हैं उतना number molecular orbital form करना है बेटा. Now number of molecular orbitals that are forming should be equal to number of atomic orbitals that are involved in the combination. That is explained on the basis of LCAO. and that I want to say here, the two atomic orbitals to produce two molecular orbitals. I think some technical issue or the problem due to the whether this is why the sound is hesitating and vibrating, maybe because of rains around us, okay, bonding and anti-bonding. When two atomic orbitals are combined, should give low energy orbital, that is called bonding molecular orbital, and high energy orbitals, that is called anti-bonding molecular orbital. So with that say, when this combined and this is going to be bonding molecular orbital, so more electron cloud between two bonded atoms are formed, that is called bonding molecular orbital. And this is called anti-bonding molecular orbital, where this electron cloud is going away from the nucleus, is called anti-bonding molecular orbital. उसमें आपको नोड भी दिखाई देता है, and it is going to be two types, feature 4, and it is going to give types of molecular orbitals. So when two atomic orbitals combine, what is atomic orbital? It's just like an electron is a wave. So the waves of two atoms are combining, so they can combine by addition of the waves or the subtraction of the waves. When they add now forms bonding molecular orbital, they subtract now the destructive interface में anti-bonding molecular orbitals are going to be formed. So you have two types of molecular orbitals. One is BMO, bonding molecular orbital, LIBA, that's good, and ABMO, anti-bonding molecular orbital, उसमें कम energy आना है, and this is having the more energy and less stability, and less energy and more stability. As you know pretty well, energy is inversely proportional to the stability, is inversely proportional to the energy. Fine, that's good. Very good number of students are gathering over here. So let us break these obstacles of the technical issues that happen due to weather, internet, whatsoever it may be. So let us chill with the subject, and we can see bonding molecular orbital stabilizes and anti-bonding molecular orbital destabilizes. Because it stabilizes, has less energy, and destabilizes, it is going to be a more energy. Okay, here linear combination of atomic orbitals, this is popularly said to be LCAO. Linear combination of atomic orbitals, this is the technical explanation for the molecular orbital theory. You need not have to worry to explain the entire the NEET examination is not a essay writing combination, rather it is a multiple choice questions where you are going to see the important noteworthy points. There you are going to observe what is MOT, and you can see wave X and wave Y of an atom here or another atom here. These two waves are combined, no? You are going to give another wave, you know, wave mechanics or quantum mechanical model of the atom, उसमें explain करना है, right beta? And these two waves can be combined in two ways, whether it is going to be a bonding interface and anti-bonding interface. When two waves combine, no, they are going to be additive waves. So where A and B are the atoms over here, and the combining wave functions are in the same phase, mean to say two waves are being added. When two waves are being added, it is going to be psi BMO will come. I mean to say here, look at this. This is a wave, and this is a wave. Okay, and these two are going to be added, so that you are going to see a bigger wave. It goes like this. So this gives you bonding molecular orbital. That gives you psi A plus psi B. This is called constructive interface. Constructive interface gives you bonding molecular orbital beta. And when you say anti-bonding molecular orbital and bonding molecular orbital, the wave amplitude is increased and electron density increases in the internuclear region. So as a result, you can see this amplitude is added, hydrogen atom and hydrogen atom बीच में. So जैसे graphs आपका options में दिखाई दिया जाता है, and you have to identify whether it is a BMO or anti-BMO. And you can see here, this is This graph is about BMO. Ankit, at least you ask a faculty, na, how are you, right? And you can see linear combination of atomic orbitals. Destructive interface में क्या होगा? 2a BMO anti-bonding molecular orbital कैसा होगा? Where A and B are the atoms. When you say combining wave functions out of phase, मैं क्या करना बोलना चाहता हूँ? Here this is a atom A combined with this is atom B. So you are going to get a destructive interface. So this is what is called anti-bonding molecular orbital. It is given by destructive interface psi A minus psi B. It is going to be psi A minus psi B. Rehan? So this gives you anti-bonding subtractive interface or destructive interface gives rise to more node is there between the bonded nuclei. So electron is going away from the nuclei, bonded nuclei. This is what is called anti-bonding molecular orbital is formed. So electron density in BMO and anti-BMO molecular orbitals which have the higher energy than combining atomic orbitals. No, molecular orbitals which have the higher energy than combining atomic orbitals are called anti-bonding molecular orbitals. Fine. And here you can see anti-bonding molecular orbital, it has a less interface. So you can see a node here, you can see a node over here, right? So more number of nodal planes are there in anti-bonding molecular orbital, less number of nodes are there in bonding molecular orbital, right? So this is the graph for the BMO. And talking about so the type of molecular orbitals, you have sigma molecular orbitals and you have pi molecular orbitals. So in the LCAO you can see sigma s orbital, sigma star s orbitals. This gives you bonding molecular orbital. This gives you anti-bonding molecular orbital on the real time images. Main postulates of so this is the main postulate of molecular orbital theory. So generously you can say the postulate of the molecular orbital theory simple. When atomic orbital combines, you are going to get a molecular orbital with low energy and with higher energy. Low energy is called bonding molecular orbital, high energy is called anti-bonding molecular orbital. So the number of atomic orbitals combines is equal to the number of molecular orbitals that are formed. Simple. And जैसे आपको atomic orbitals में electrons होगा, molecular orbitals में भी electrons होगा. So these electrons are filled in the molecular orbitals according to Aufbau rule, Pauli's rule, Hund's rule. Right? And if they form sigma bond and pi bond, I am going to show you the various types of orbitals that is called. But to find, now let us see here, this gives you bonding molecular orbital, anti-bonding molecular orbital. If you see, this was the s orbital. When you see this p orbital combines na molecular orbital of the sigma bond is formed. They can also form pi bond. This is how the sigma pz orbital is formed. Let us see, this is anti-bonding orbital can also be formed here. That is, if you see here plus and plus combines, no, that forms bonding molecular orbital. Plus and plus, positive overlapping. Yes, if it is plus and minus, it is going to be out of phase. It is going to give you anti-bonding molecular orbital, mind it. So that is called a destructive interface out of phase. That is the importance of the plus and minus. Okay, Z is the internuclear axis. The imaginary line that connect with the bonded nucleus is called internuclear axis. That's what you want to say, LIBA. And similarly, you can say these PY and PY or PZ and PZ. So plus and plus are combining. This is called pi bonding molecular orbital. You are going to see this is called, it could be PY or PX orbitals. And you can see destructive interface or outer phase, so it is going to be pi star anti-bonding molecular orbital. You understand? Clear? That's pretty clear. Laiba, understand Beto? Rehan? Be clear. If you have any doubt, please ask us. I think voice is now it is pretty clear. Voice is now it is pretty clear. That's good. Now conditions for LCAO. That is pretty clear. What are the conditions? Combining atomic orbitals must have the same or nearly same energy. Then only LCAO takes place. Linear combination of atomic orbitals takes place. Otherwise, this LCAO do not take place. Conditions for LCAO, otherwise the combining orbitals must have the same symmetry about the axis. Voice is breaking, Maran. Okay. So I mean to say the direction of the orbital should be like this. So you want to say px orbital. If you say py orbital, they cannot form a sigma bond, right? And quick contrast, you can say bonding orbital, anti-bonding molecular orbital. So may or may not have the same nodal plane for bonding orbitals, but definitely anti-bonding molecular orbitals will have a nodal plane or more than one nodal plane. And also say it represented by sigma 1s, sigma 2pz, sigma 2px, sigma 2py, where anti-bonding molecular orbitals is shown by a star. If star is there, anti-bonding molecular orbital. If star is not there, bonding molecular orbital. You understand? That's fine. Now you can see. So I want to say molecular orbital diagram up to 14 electron system. So for that you need to have 1s is less than sigma 1s is less than 2s, sigma is less than sigma 2s is less than pi 2p x, pi 2py less than sigma 2pz is less than pi star 2px and pi star 2py and sigma star 2pz, right? So this is up to nitrogen it is true. Up to nitrogen it is true, and you just take the electron configuration and write according to it. Total number of electrons you can write it, and you can calculate the bond order and magnetic moment bus. I am going to give you the trick for this as well. Now you can see energy level diagrams. This is the energy scale. If 1s orbital and 1s orbital combining according to this 1s orbital and 1s orbital, this is your 1s orbital beta and this is 1s orbital beta beto. So 1s and 1s combined to gives rise sigma 1s and sigma star 1s. I want to say it is going to give you it is sigma 1s and sigma star 1s, right? So it is very very important, clear? And उसमें जितना number electron है, you have to identify according to the half-bow rule. Now this is atomic orbital. Atomic orbital gives rise a molecular orbital. Learning is a process. Do like this. Students, please like the session who are online. Please like the session. Now let us talk about the p orbitals का कहानी क्या ऐसा होगा. So in the p orbitals you have 2px, py and pz, and this is your energy beta, and this is your energy, and this is a px, py, pz. These 2, 3 are combining to gives rise. For up to nitrogen you are going to see px and py then pz, so it is going to be star nahi hoga usme, and it is going to be pi star x and pi star y and pi star z. So the electrons are filled in this order only, right? Now this is atomic orbital, this is atomic orbital, and they are going to give the molecular orbital. Now so molecular orbitals from oxygen onwards kaise likhna hai? After this I am going to show you the simple trick that you can do it, right? What are the simple trick? First let us see here. So that is going to be the only difference. 1s less than sigma 1s less than sigma star 1s less than 2s, sigma star 2s. Now sigma and pi comes the variation in the previous up to 14, and it is simply swapped, right? So this is a very, very important, and generally we follow this order. Only in the case of up to boron, carbon, nitrogen and below that you are going to see the previous version. Okay, उसमें pi orbitals पहला आना है, उसमें sigma orbitals पहला आना है, ये actual order, right? It is very, very important. Everybody takes a screenshot of this, dear children. Everybody takes a screenshot of this. Now what will happen here? The energy scale, so that p orbitals are combined first 2pz, pi px, pi py, pi star px, pi star py and 2pz. So it is going to follow this order. You understand? Fine. And you see here molecular orbitals and atomic orbitals are shown like this. And features of molecular orbital theory, feature 5, फिलहाल 4 features दिया. Feature 5, orbitals are filled according to Aufbau rule. Aufbau rule क्या कहना चाहता हूँ? Electrons are filled in the orbitals in increasing order of these energies. And Hund's rule, while filling degenerate orbitals mean to the same energy state orbitals, pairing cannot take place unless their orbitals are half filled with parallel spin. And Pauli's exclusion principle, no two electrons can have the same set of 4 quantum numbers. So I mean to say, in the orbital, maximum of 2 electrons with opposite spin are going to be permitted, right? And bond order. So the bond order is the number of bonds between 2 atoms. I mean to say, that is going to be number of electrons in the bonded molecular orbital minus number of electrons in bonded molecular orbital by 2. So bond order, simply you can calculate number of electrons in bonding molecular orbital, number of electrons in anti-bonding molecular orbital by 2. If bond order is 0, such bond never exists. If bond order is 1, single bond exists. Bond order is 2, double bond exists. Bond order is 3, triple bond exists, right? So existence of a molecule, अगर bond order आपको पता चला, अगर bond order you can see it is a value, if a 0 it do not exist, and if it is a negative never exist. So molecule never exists, mind it. Bond order can tell you the story, right? And also you can see if it is a hydrogen is 1s1. If H2, how H2 is formed? Hydrogen molecule मिलके H2 मिलेगा. H2 में 2 electrons. 2 electrons are written sigma 1s2. So its bond order is going to be 2 minus 0 by 2 is equal to 1. Single bond between 2 hydrogen atoms exists like this. Similarly, if you want to talk about the helium, so oxygen 1s2 2s2 2p6 2 oxygens, oxygen मिल गए O2 बन गया. O2 में 16 electrons हैं. These 16 electrons can be written as, you can see, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, and pi 2px2, pi 2py2, and pi star 2px1, pi star 2py1. You see, this is the important, right? And in this scenario, you can see this is a paramagnetic. When you talk about the bond order, it is going to be number of electrons in bonding molecular orbital minus number of electrons anti-bonding molecular orbital. Bonding molecular orbital are 10 electrons, ABMO 6 electrons. So it is going to be 10 minus 6 by 2 is equal to 2. Therefore, oxygen to oxygen, a double bond can be seen. Can you see the double bond here? This is a bond and this is a bond. Bacho? So like that you can say. And you know, this bond order can tell you the stability of the molecule as well. And I'm going to show you that. And nitrogen, 1s2, 2s2, 2p6. 1s2, 2s2, 2p3. Total 7 electrons are there. 2 nitrogen milke. Nitrogen plus nitrogen gives rise nitrogen molecule. 14 electrons. These 14 electrons can be written as sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Now pi orbital पहला आना है. So that pi star 2px2, pi star 2p/2, sigma star 2pz2, it is no unpaired electron, it is diamagnetic, and it is going to be number of bonded electrons are going to be 10, anti-bonding molecular orbitals are going to be 4, divided by 2 is going to be 3. So you are going to see triple bond is seen here, nitrogen to nitrogen triple bond. Similarly, carbon molecule also seen. Carbon, it is going to be 1s2, 2s2, 2p2. So 1s2, 2s2, 2p2. Right? So sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sig pi 2p x2 2p y2, it is diamagnetic. Okay, like that you can do. Now I just want to say bond order. This bond order can give you so many important informations better. That is, bond order is directly proportional. Bond strength, I want to say bond energy is directly proportional to bond order, and bond stability and the stability of molecules is directly proportional to bond order, and bond length. So longer the bond, shorter is the bond, stronger is the bond, longer is the bond, weaker is the bond. So that bond order, bond length, I just want to say here, bond length inversely proportional to bond order, and bond dissociation energy or bond energy and the stability are in the same way. Right? You want me to give the trick, bacho? I'll give you. HOMO and LUMO is very important, that is highest occupied molecular orbital, lowest unoccupied. Hi everyone, Roni. Okay, so highest occupied molecular orbital, what is the meaning of that? Lowest unoccupied molecular orbital. Okay, no problem, some tech issue is there, let us say, because of the heavy rains and all. So HOMO, LUMO, these terminologies are very important for NEET examination. Bacho, now you can see here, highest occupied molecular orbital, you can say it is called HOMO, lowest unoccupied molecular orbital, it is called as a LUMO. And how to figure out this? Okay, right, no problem, it is a self-explanatory, we can do it. And C2 molecule, you see, when you see this is your C2 molecule, and you can identify some orbitals over here, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2p x2, pi 2p y2. Now in this, what it is called as highest occupied molecular orbital, this is your highest occupied molecular orbital, and it is ये among this molecular orbital, उसमें ये highest occupied है, उसमें lowest occupied है. Okay, that is called LUMO, HOMO, right? Identification is important. Always electron enters into the HOMO. Both are molecular orbital, bonding molecular orbital, right? And this is how it is clearly shown, so that the terminologies are very important. And I want to say bond order, already we discussed this, and unpaired electrons can give you the picture about the magnetic moment. Magnetic moment is calculated by using this formula, mu is equal to root over n into n plus 2 Bohr magneton, where n is equal to number of unpaired electrons, maybe in the bonding orbital or anti-bonding orbitals, let it be. So I want to say Bm stands for Bohr magneton is the unit beta. In this, it is unit of the magnetic moment. If n is equal to 0, then mu is equal to 0. So such compounds are non-magnetic, diamagnetic. Such is called diamagnetic. Okay? If n is greater than 0, mu is greater than 0, such is called paramagnetic. Such are called paramagnetic. Fine? And you can just take these paramagnetic substances will have the magnetic behavior. And moving ahead, bond order we already discussed. I just want to talk about a trick. This is your super amazing trick, bachcho. Super amazing trick. Everybody can use this. Now, you write the number of electrons as 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So, this you just take 9 to 20 na, or 10 to 20 you can write. So, you start with 0.1, add 0.1, 0.1, add 0.1, add 0.1, add 0.1, add. Maximum it becomes 3.0. And decrease 0.5, 0.5. So, 0.5 se 0.5 add karna, 0.5 se you keep adding 0.5. So, reach up to 3.0. Up to 3.0, decrease 0.5, 0.5, 0.5, 0.5, 0.5. So, the number of electrons can give you the bond order. Definitely you can write the bond order as well as the stability, bond length and everything. That can give you direct impact. Whenever you can see odd electrons in the molecular orbital configuration, you are going to get a paramagnetic behavior. When you are going to get unpaired electrons 0, it is going to be diamagnetic substance. Now, I just want to say here, what is the magnetic moment of nitric oxide? Nitric oxide. Apply the formula. Nitrogen plus oxygen gives rise nitric oxide. So, it has 7 electrons, it has 6 electrons. 7 plus 6, okay, it is going to be 13 electrons, right? So, 13 electrons, उसमें 13 electrons का क्या होगा 2.5. It is going to be paramagnetic. Yes, it is going to be. So, 7 plus, yeah, total valence electrons is going to be, it is 8 na, okay. 15 electrons. 15 electrons means it is going to be 2.5. Again, it is going to be 2.5. You can see 2.5, right? Now, it will be 2.5. Simply write the electron configuration, calculate the bond order. Again, 2.5. You got it now? Fine. Or I want to say carbon monoxide. How do you do for the carbon monoxide? Let us talk about the carbon monoxide. Heteroatomic or homoatomic, doesn't matter. It is going to be 6 electrons, it is going to be 8 electrons. You are going to get 14 electrons, you know? It is a 14 electrons. When you have this 14 electrons, you have bond order is going to be 3, bond order is going to be 3.0 you can say, right? So, like that you can have various types of calculations. I want to say O2 2 plus and O2 2 minus and O2, right, and O2 plus and O2 minus. How many electrons you have in the O2? It is simply say, apply this is going to be 16 electrons now. You add this is going to be 17 electrons now. You are going to get 15 electrons now. You are going to get 18 electrons and you are going to get 14 electrons. Now, you simply see the number of electrons and you can say what is the bond order. What is the bond order, my dear children? Bond order is O2 16 electrons. 16 electrons means it is going to be 2.0, that is the bond order. And 18 electrons 1.0. Hope you are understanding clear. 1.0 and 14 electrons ka 3.0 and you say 15 electrons ka 2.5 and 17 electrons ka you see 17 electrons ka 1.5, right? You have various bond orders here. You have various bond orders. Now, the order of stability. Can you say the order of stability? Order of stability is directly proportional to the bond order, बच्चों. Beto, Maran, Laiba, follow this. So it is going to be O2 plus is greater than O2 plus is greater than O2 greater than O2 minus is greater than O2 2 minus. Exactly. So when you just say about the bond order, it is important to know what exactly the bond order tells you. And this is a super amazing trick that can help you to answer various questions from the NEET examination. Of course, I still agree there is some kind of technical issue that is going on with the network. I have to connect to the YouTube team and they'll come back to you, and hope you understand with this awesome trick, and everybody take a screenshot of this and can do awesome number of questions based on this trick. Take 3, 2, 1 and we'll see, and we'll meet with more stuff in the next class. We are done from our side. Thank you very much. Signing off, Suresh, Faculty of Chemistry from Infinity-level. Please like this session, share it with your friends, उन लोगों को भी फायदा होना चाहिए, and subscribe to Infinity-level NEET YouTube channel. Thank you very much.